These are the 4I notes on the constant of proportionality. In this first example, it says, the car paint company provides a perplexing pay graph for new managers. What does the graph show? Which point, A, B, or C, might be the most useful? Explain. So here we have a graph, a manager pay graph. We have the money earned on the y-axis and the hours worked on the x-axis. So when we look at this graph, we can see that in 1 hour, $10 was earned, and that's point A. In 5 hours, $50 was earned, and that's point B. And in 8 hours, $80 was earned, and that's point C. So which point do you think would be the most useful? The graph shows the amount of money a manager would make for various hours worked. So that answers the question, what does the graph show? Now to answer the question, which point might be the most useful, point A shows how much money a manager earns in 1 hour. So this is actually the unit rate. Remember, the unit rate has to do with 1 unit, and that's always going to be on the x-axis where you'll look for the 1. This information can be used to easily find the amount of money earned for any number of hours worked. So if you knew how much is earned in 1 hour, you could figure out how much is earned in 2 hours, 3 hours, 8 hours, or 40 hours. The next question asks, which point may be the least useful, and explain. So looking at those 3 points, point A is clearly the most useful. If we look back at the graph, we can see that point B shows how much money is earned in 5 hours, and point C shows how much money is earned in 8 hours. Well, a typical workday is 8 hours long. So that means that point B would be the least useful because you usually don't think of work in 5-hour segments. Knowing your hourly pay, point A, or your daily pay for 8 hours, point C, seems the most useful. Make sure you turned your notes to the next page. Recall that two quantities x and y have a proportional relationship if y is always a constant multiple of x. The constant multiple, when we take y divided by x, which is that number that's the same every time, is called the constant of proportionality. If x and y have different units, then the constant of proportionality can be written as a unit rate. For example, there is 1 brick with a length of 20 centimeters. This means that the proportion of the total length to the number of bricks is 20 to 1. Therefore, the unit rate is 20 centimeters per brick. So when you're writing a unit rate, you need to make sure to include your units. The only reason why we don't use a number in the denominator is because it's out of 1, so it's not necessary to say 1 brick. Complete the table for 1, 2, 3, 4, and 5 bricks. Find the proportion of the total length to the number of bricks. So as we were already told, 1 brick has a total length of 20 centimeters. So if we complete the table for 2, 3, 4, and 5 centimeters, and we know that 20 centimeters is for 1 brick, we would know that for 2 bricks it would be 40 centimeters, 3 bricks is 60 centimeters, 4 bricks is 80 centimeters, and 5 bricks would be 100 centimeters. This means that our ratio of total length to number of bricks, which would be y divided by x, is 20 over 1, which equals 20. If we do the same thing for the rest of the table, for 2 bricks, it would be 40 over 2, which equals 20. For 3 bricks, 60 over 3, which equals 20. 4 bricks is 80 over 4, which equals 20. And 5 bricks is 100 over 5, which equals 20. The next question says, what is the unit rate for 2 bricks? What about 3, 4, and 5? Well, if you're trying to find unit rate, the unit rate is 20 centimeters per brick for all amounts. So the unit rate occurs when you actually simplify to that ratio that we get for each of the options. This means that the constant of proportionality is 20 centimeters per brick. So your constant of proportionality is the same as your unit rate. It's just that with a unit rate, you're actually going to include the units, centimeters and bricks. Turn your notes to the next page. Question 1 says, the weight of the stack depends on the number of books in the stack. Identify the constant of proportionality in this situation. Then use the constant of proportionality to find the weight of 11 books. So here we have a picture of 3 books that weigh 5.25 pounds. The constant of proportionality is always going to be y divided by x. X is always going to be the independent variable, and y is always going to be the dependent variable. That's something that you'll want to memorize. The weight of the stack over the number of books is 5.25 pounds for every 3 books. That equals 1.75 pounds per book. The way that we know to take the weight of the stacks divided by the number of books is because the weight of the stack depends on how many books there are. So the dependent variable is always going to be the y value on top, and the independent variable will be the x value. So whatever depends on the other is always going to be in the numerator. That's our y value. To find the weight of 11 books, all you have to do is take the pounds per book times 11, which means it's 19.25 pounds for 11 books. Question 2 says each shoebox is the same height. The height of the display depends on the number of shoeboxes in one column of shoeboxes. What is the constant of proportionality for this situation? So we can see that it's 45 inches for 1, 2, 3, 4, 5 shoeboxes. We know that we have to put our dependent variable over the independent variable. The height of the display depends on how many shoeboxes there are. So depending on how many boxes you place, that will determine the height, which means we're going to take 45 inches divided by 5, our dependent divided by our independent variable. 45 divided by 5 gives us 9 inches per shoebox. That's our constant of proportionality and our unit rate. Question 3 says you have a recipe that calls for 2 cups of flour to make 3 dozen cookies. Your friend has a cookie recipe that calls for 3 cups of flour to make 60 cookies. Are the constants of proportionality the same for the 2 recipes? Are the recipes for the same cookie? How do you know? So for your recipe, we would take the number of cookies divided by the amount of flour, because the number of cookies depends on how much flour is used. There are 36 cookies for every 2 cups of flour. So we would take 36 divided by 2 to get 18 cookies per cup of flour. Your friend, in the recipe, if you take the number of cookies divided by the amount of flour, you would get 60 cookies for every 3 cups of flour. That is equal to 20 cookies per cup of flour. You can see that we did not get the same answer. So that means no, it is not the same. Each recipe makes a different amount of cookies per cup of flour. Question 4. You run on a treadmill daily at a constant speed. On Monday, you ran 2.25 miles in 22.5 minutes. On Tuesday, you ran 2.35 miles in 25 minutes. Are the constants of proportionality the same for the 2 days? How do you know? So for this question, on Monday, we ran 2.25 miles in 22.5 minutes. That is equal to 0.1 miles per minute if you divide 2.25 by 22.5. The reason why we're taking miles divided by minutes is because the number of miles depends on how many minutes you run. If you run more minutes, you'll run more miles. If you run less minutes, you'll run less miles. So we'll do the same thing for Tuesday. You ran 2.35 miles in 25 minutes. That's equal to 0.094 miles per minute when you divide the 2 numbers. This means no, they are not the same for the 2 days. The miles per minute are different. Question 5. The table shows the amount of money raised based on the number of tickets sold for a charity concert. Does the table show a constant of proportionality? If so, what is the constant of proportionality for this situation? So if we look at the table and we take the money raised divided by tickets sold, you get 22.50 every single time. So $22.50 per ticket. We get the same thing every time with y divided by x. Part B says you can sell no more than 2,500 tickets for the concert. Find the maximum amount of money the fundraiser can raise. Well, if it's $22.50 per ticket, you would need to take $22.50 times 2,500. That means that the maximum amount of money raised is $56,250. Question 6 says the table shows the time it takes to pump gasoline based on the number of gallons pumped. What is the constant of proportionality for this situation? So to find our constant of proportionality, remember, you're always going to take y divided by x. Y divided by x. Do the same thing every time. When you do that, you end up getting choice A, 8 seconds per gallon. Question 7. The graph shows the number of times a male hummingbird beats its wings based on time. What is the constant of proportionality for this situation? In order to find the constant of proportionality, what you need to do is look for your unit rate. So go to the x-axis and look for where it says 1. Follow up and over on the graph. If we do that in this situation, we find that it's 80 wing beats per second. And then it says, what does the point 1, 80 represent? Well, the point 180 represents that 80 wing beats in 1 second. That's our unit rate. So if we look at the graph, anytime you're trying to find the unit rate, remember, unit rate has to do with 1 unit. So you just look on the x-axis for the 1, and that's our time. You follow up and over to see what lines up on the graph, and that would be an 80. So it would be 80 wing beats per second, because remember, it's always y over x. Question 8. The graph shows the distance a cyclist traveled based on time. What is the constant of proportionality for this situation? Remember, the constant of proportionality is the same as our unit rate. So if you look at the graph for the unit rate, you would find that the answer is C, 20 kilometers per hour. Now that you have finished the 4I notes, please show them to the substitute. Then you will be given 4J. That's your homework for tonight. If you finish early, work on any missing work or your skills checklist worksheets.